Lachlan Rogers, give him a big hand.
Now, I'd like to talk to you for a moment about the sounds of quantum. And this project grew out of a podcast called Clear as Quantum. And when you're doing a podcast, you can't show pictures. So you're talking to quantum scientists about their technology, and all they can refer to is sounds. So, do you have any sounds that you associate with the word quantum? That's a question for you to ponder. Here are a couple that came up in various episodes of our Equus podcast. This is me. I'm an experimentalist. I work in a lab, and let's see if we can hear briefly what the lab sounds like. That is the sound of quantum. A humming background noise that is slightly above OH&S decibel levels. But lots of my colleagues work with equipment that looks like this, which takes things down really, really cold, and they get rhythm. That's the sound of helium pulsing through the fridge tubes to get that lump of metal down to being one of the coldest places we know of in the universe. Some other sounds that people have given as answers. This is the sound of a Geiger counter measuring background levels of radiation slightly above safe limits. And when you're hearing those clicks, each individual click is one individual particle of radiation already. We're talking particles and waves and sound, and we're well into the journey of quantum physics. Was this on your list? This is a sound of quantum for one of my colleagues. It's the theme from The Third Man. It's played on the zither, and it was very specifically called out as a sound of quantum by my colleague Magdalena, who works up in Brisbane. And the reason is that it was used as the background sound for an animation she saw that was formative in her journey into quantum science, showing the way that single molecules can interfere with each other like waves, even when they arrive one particle at a time. So there's a lot of sounds here, and in fact, one of the other sounds that comes up that's a sound of quantum is just the sound of silence. One of my colleagues worked with a metal bar that he cooled down to so low temperature that even if you tapped it once, it would ring for 2 days, and that was what he didn't want. So silence was the goal there. Now, in my research in the lab, I shine lasers at diamonds to make them glow, and I'll admit that gives me an unfair advantage when talking to the ordinary people in the room, because my science is cooler than almost anyone else's. But one of the challenges here is that the brightness of the red glowing light actually varies with a magnetic field, but our human vision sense is not very sensitive to small changes in brightness. So when I wanted to show this to people, I realized that our sense of pitch, hearing a tone, is much more sensitive. What you are hearing is the brightness change of that red glowing diamond. You can't see it change because your eyes don't detect 15%, because brightness is logarithmic for the people that care. So that is a sound of quantum. Those are a single electron spins telling you about a magnetic field being right near them. These are a couple of sounds of quantum, and this one got me on a little bit of a journey. I wondered how much else could we use our sense of sound to understand the quantum realm in which we live. Here's a story about a thing in a box. And when physicists say thing in a box, we sort of mean particle, but we draw it as a wave. You can see this is a wave because it's a humpy line, and it's got just one loop in it. So that's just one wobbling line like a guitar string or a skipping rope at school. And it sounds like this. That's us listening to the ground state of this thing in a box. And the next state of the thing in the box looks like this. Obviously, it has to have two humps. This is the quantum story. It can't have just 1.5. It can only have 1 or 2. And if you listen to this one, it's got to sound different. And it does. So there's the sound of two states. What would it look like if we put this thing into a Schrödinger cat state, a superposition, where it's both of those states at once? I can draw it because I can do maths. We just add these things together. What would that sound like in our ears? Can you hear that there's both pitches there at the same time? In fact, we can adjust the volume contribution of each of those frequencies, which is exactly what you can do with a superposition state. So this is a pretty good way to hear a Schrödinger cat state. This thing in a box, though, has even more states than just those two. So if we looked at just the first 4 states in a 4-way superposition, we've invented the clarinet. And in fact, by changing the amplitudes of those different components in the superposition, we could change this clarinet into a flute, and we could do all sorts of things. That's the basis of most synthesizers. So this is what superpositions sound like. This is hearing the quantum science that underpins the second quantum revolution. And with this idea in mind, you've heard a few tones. I would like you now to listen to a brief excerpt, by far the most intriguing answer to the question, what sound do you associate with quantum science, that I have received, is the following one. Professor Helena Rubinstein Dunlop from the University of Queensland, who is an Equus chief investigator and, I understand, was the first female full professor in physics in Australia, deserves a shout out. Thank you. She gave me the answer that for her the sound of quantum is this song. It's called Für Alina, and it was composed by Arvo Pärt. Obviously, that's only an excerpt, but every single one of those notes, you could hear the different frequency components, so each of those notes was a superposition. When we changed from one note to another note, we must have been changing the size of the box that this thing was in, which is like doing a quantum logic gate on a superposition and maintaining the coherence of the state. In some ways, although Arvo Pärt probably never thought of it this way, that song is the audio experience of quantum computing. And Helena didn't describe it quite that way. She described it as being the feeling that she thought a quantum sound should have. But she was visionary when she gave me that answer, because what she has described, what she has identified, is a piece of music that is 100% quantum from top to bottom. And I think that's an exciting discovery. Such an exciting discovery, in fact, that I would like to suggest, it's too late, Equus is getting close to the end, but maybe this is a pitch for a future ARC Centre of Excellence. I think we should be talking about orchestrated quantum systems. If you've liked the sound of quantum, you may be interested in listening to a few episodes of the Clear as Quantum podcast, sponsored by Equus, and thank you very much for listening tonight.
Lachlan Rogers, Clear as Quantum.